Hey, welcome everyone. So today I'm going to talk to you about the vision for OpenStack Clouds, which is an exercise that the Technical Committee has gone through for OpenStack to try and write down a common vision across the community for what we believe the problems that OpenStack should be solving for users, basically. So we're looking at it from a user perspective. What should OpenStack do? What should it include? So you may or may not be familiar with the OpenStack mission statement. You'll be able to see by reading that we've tried to cram quite a lot of detail in there, but there's still not enough detail for teams to really work on. There's nothing actionable there that teams can know how they need to work together to build a cohesive product or a cohesive set of projects. So that's kind of one of the reasons why we embarked on trying to write down a more detailed document. So before I go too much further, I know you're all going to go look up this document afterwards, so you can find it on the TC's governance site at governance.openstack.org. You can just search for Vision for OpenStack Clouds on that page and you'll find it. Or if you're otherwise so inclined, the QR code there should take you directly to it. So as I said, this document is looking at OpenStack from the user's perspective, so we're only worrying about the user-facing services and what they should do. So there's a lot of other parts of OpenStack, obviously, deployment tools and that kind of thing. They're still part of OpenStack, they're still important, but we're not talking about them in this document. So we kind of divided this document into three sections. First section, the pillars of cloud. So these are the things we believe that apply to every cloud. So number one, clouds are self-service, right? So back in the days of early days of virtualization, virtualization was controlled by your IT department. If you wanted a virtual machine, you went and raised a ticket, and they got your virtual machine. And cloud is not like that. Cloud is self-service, so you have an API, you can go say, give me a machine. And there are some direct consequences from that. So if you're going to allow people to be self-service, then you have to have robust multi-tenancy. You have to have usage controls, things like billing or quotas or both. And so that's one part of the story. And it's probably the part that you most know about OpenStack, because OpenStack is very good at that part. The second part we think of cloud is that the cloud is application-facing. So it's not something that relies on a user sitting in front of it and clicking buttons necessarily. The application itself should be able to access the cloud's APIs and control stuff autonomously. So you can think of things like auto-scaling, that kind of thing. That should be something that the cloud supports. And again, this has consequences for design. So you need to have API access for applications. You need to be able to have your application authenticate to the cloud APIs, preferably with least privileges, so that the application can only do the things you want the application to do and not everything that you can do. And OpenStack isn't yet as good at this part. So this is kind of one of the areas we need to work on, and hopefully by writing this stuff down, that's something we can help projects kind of focus their minds on yes, okay, this is an area we need to work on, and we need to make sure that all the projects work together on doing this. So the next section is the things that we think are specific to OpenStack and not necessarily clouds in general. So if you think of some of the big proprietary clouds, they're one cloud, but OpenStack isn't one cloud. OpenStack is a tool for building clouds, and there are lots of OpenStack clouds, and they're all different. So we have to think about things like interoperability. Can users write applications that will work the same way across multiple OpenStack clouds? Because that's where a lot of the value of OpenStack comes in. We have to think about bidirectional compatibility, not just backwards compatibility, because if you move from one cloud to another, you may actually be moving back in time in terms of the version of OpenStack that you're using. We have to be careful about cross-project dependencies, because not every operator is going to want to install all the same projects. So we have kind of some some information in there to guide projects on when is a good time to add a cross-project dependency and when's maybe not a good time, maybe you should have a soft dependency, that kind of thing. And finally, partitioning into things like availability zones. You know, we have a concept of an availability zone in OpenStack, but actually OpenStack doesn't know how you're deploying your hardware. It doesn't know whether it's a true availability zone. So in future, we want to avoid language that implies something about how the operator is deploying it that the software can't actually know. And so this section and the previous one are things that we expect every project in OpenStack to be thinking about all of these things. The third section is kind of the design goals. And these are the things we want OpenStack as a whole to accomplish for users. So we're not expecting every project to hit every box here. In fact, it would be very surprising if any project could hit every box here. But we do kind of expect every project to fit in one of these boxes. The technical committee certainly will be using these criteria to evaluate projects. If new projects apply to OpenStack, we'll be evaluating them against this and saying, hey, does this meet one of our design goals, or do our design goals need to change? Or does this not meet our design goals? Maybe this is something that belongs outside of OpenStack. So I'm not going to dig too deeply into all of these, but the first one's quite interesting, the physical data center management, because there are not really many other open source projects that are tackling this area, right? So if you think of something like Kubernetes, it assumes that the data center exists already, and you're just installing Kubernetes into it. And in OpenStack, we don't make that assumption. We know you have not only server hardware that needs to be managed, but network hardware, load balancers, those kinds of things. You have identity management providers that need to be integrated. You need to integrate with DNS. So these are all things that OpenStack handles. And it's quite important that OpenStack does handle these things. The other categories plays well with others. So we do want to integrate with things like Kubernetes. We have projects like Magnum that do that. Hardware virtualization, you know, we're not just about virtualizing servers. You know, you've got projects like Cyborg, which is, you know, handling GPUs and those kinds of things. Any hardware that you might have in the data center, load balancers I mentioned before, we want OpenStack to be able to virtualize those so that they can be used in a multi-tenant environment. So scaling infinitely and continuously. So if you think of a project like Swift, if you write your application to store data in Swift, there's no obvious limit to how much data you can store in Swift. I'm sure you'll eventually hit a limit, but it's effectively infinite. And it's continuous. You don't need to allocate a big chunk of storage in Swift. You just put in whatever objects you need, and it kind of scales up continuously. You can think of the same thing as like functions of service as opposed to VMs. So that's a direction a lot of things are going in, and that's something we want to support. Built-in reliability and durability, I mean, this helps, especially for smaller applications. It's expensive if you need to build in reliability and that kind of thing. But if the cloud can provide it for you, then you can share that across a lot of tenants and save costs there. Customizable integration, you know, OpenStack's not opinionated about how the applications on it run. You can hook things up in different ways. Specialized operations, we think of things like database as a service, Magnum for Kubernetes as a service. Those are things that you might want to have managed by a separate IT group and not have every team deal with those. And the last one is a graphical user interface, which I think is really important, especially for beginning users. So finally, this is a living document. We value input from the community, and we'd like to hear your opinions. You can contact us on the mailing list, the TC channel on Freenode, or just submit a review to this document in Garrett. And those are all good ways to contribute, so we appreciate it. Thank you.